Assalamualaikum and hi. So now we are going to look at example 4 from chapter 5. Alright, what we have here is a box of mass 20 kg moves up a rough plane which is inclined to the horizontal at 25 degree. It is pulled by a horizontal force F of magnitude 250 Newton. The coefficient of the kinetic friction between the box and the plane is 0.3. If the box travels 3.8 meter along the plane, determine. There are 5 questions here to find the work done by the force F, work done by the gravitational force, work done by the reaction force, work done by the frictional force, and also total work done on the box here. Alright, let us first understand the question. So we have a box, okay, of 20 kg moves up a rough plane, okay, which is inclined at 25 degrees. So this is the plane which is rough and it is inclined at 25 degree here. So this box is going to move and being displaced at this particular place here. So the force that we apply to pull the object here, this force has a magnitude of 250 Newton, and then the coefficient of kinetic friction is 0.3, and then the box travels up from here to here, which is the displacement here, by 3.8 meter. Okay, so as we can see in the question, we have already been given all the forces acting on the object. We have normal force, we have weight, we have external force exerted, and we have frictional force here. All these forces are given. So the first question here is to find the work done by the force. So we want to find the work done by this particular force. And we know the equation for work done, W is equals to F dot S. So the force that we are talking here is the external force. So F S cos theta, where the magnitude of force given such as 250 Newton, and the displacement the object went up to is by 3.8 meter. So what is the angle between our F and also S? Because the theta here is the angle between F and S. So as you can see here, the object is displaced in this direction. It has traveled from here to here. Okay, so this is the direction of S, and the force is applied in this direction here. Okay, so this is the F here. So the theta that we are talking is this particular theta here. Okay, so what are we going to do here is, we know the plane here is going to act as our x-axis. So this is my x-axis, and this is my y-axis here, right? So the W is going in this direction. So from here I know the theta here is 25. Since this is forming a perfect right angle triangle here, therefore this one here will lead to 90 minus 25. 90 minus 25. So I'll get 65 degree here. Alright. Sorry. Not here. Here. This is what I meant. 65 degree here. My bad. Sorry. 65 here. And then as you can see, this is a right angle triangle as well. So if this is 65, you're going to get this one as 25 here. Okay, and then look at here, the F and the W here is another 90 degree. If this part here is 25, this whole thing, the angle between the y-axis and the force becomes 90 minus 25, which is 65. Therefore, the angle between the force and the x-axis becomes another 25 here. Our S, the displacement of the object, is along x-axis. You travel from here to here. So your displacement is on x-axis. The angle theta here is between the F and the S. Therefore, theta here becomes 25. So cos 25. So you need to press your calculator. 250 times 3.8 cos 25, you'll get 860.99 joule. You managed to find the work done by the external force. And then next we are going to find the work done by the gravity. So B here is the work done by the gravity. Since it is a work done by gravity, I'm going to substitute the symbol weight for the force here, W dot S. This W is not the work, this is the weight force. Becomes WS cos theta. Okay, W adalah mg, mass times gravity. Mg S cos theta. So my m here, the weight of the object is, the mass of the object is 20. Multiply with 9.81, the gravitational here. Then the displacement is by 3.8, and then cos the angle between W and also S. So this is your W here. This is my W here. And my object is being displaced along x-axis here. So the theta that we are talking is from the x-axis to the W. It's the purple color. So what happened here? The theta here becomes 25 plus 65 plus 25. You get 115. So you're going to get a theta of 115. So 20 times 9.81 times 3.8 cos 115. So we'll end up with negative 315.09 joule. Okay, so this is the this is the work done by the weight force. And then next we're going to look at the work done by the reaction force. Okay, so the reaction force here is the normal. Okay, this is the reaction force. This is the reaction force, N here. So the work done by the reaction force, which is also known as normal force, is N dot S, where you get NS cos theta. We do not know the value of N. You have to find the value of N actually. How do you find the value of N? Is you're going to resolve your chapter 4. You're going to go back to your chapter 4. You're going to use the table, X component, Y component, and then deduce your N here. However, there is a tip. Always check the theta first. Okay, before you find your N, you check your theta first. What is the theta between the normal force and the displacement here? Normal and the displacement. The object is displaced along x-axis and the normal force is along y-axis. As you can see, the angle between them is 90 degree. Cos 90 here, cos 90 gives you 0. Okay, so anything multiplied with 0 is a 0. So don't bother finding the normal force. You can straight away write it as 0 joule here. And then next, we're going to look at the work done by the frictional force. So frictional force here is F dot S cos theta. Okay, so as you can see, the value of the frictional force is not given in the question. However, we know we can find frictional force by using mu n. This is the equation that we have encountered in chapter 4. So I'm going to substitute mu n s cos theta. Alright, mu n s cos theta here. Mu is given in the question. N is something that we do not know. S is given. And then the theta here is the angle between the frictional force and the displacement. As you can see, the angle between them is 180. 180 cos 180 gives you negative 1. That means you have to find your normal. Tadi kita dah escape daripada cari normal force punya value sebab we know the theta here is 90. So this leads to 0. Therefore we get 0 joule. Tapi dekat sini tak nak terpaksa cari. So how are you going to find adalah you're going to solve your summation y here. You're going to solve your y axis in order to get your normal force. Okay, so we're going to only look at summation Fy here because the normal force is along y component. Summation Fy is going to equals to 0. Kenapa 0? Because the object is not moving along y component. So acceleration along y adalah kosong. Summation Fy, summation F should equals to ma, Newton cakap. Betul? However, you have to look at the acceleration. Is your object moving along y component? No. no movement along Y component, so acceleration 0. So the total force along Y pun 0. Okay, look at the diagram here. Alright, look at the diagram here. We're going to identify the forces along Y component sahaja. Kita ada normal force along Y. Alright, kita ada normal force along Y. This is very confirmed. And then look for other forces. Do you have any other forces along Y? Okay, kalau kita tengok secara kasar memang tak ada. However, as you can see, your force, external force and your weight are in between X and Y axis. Since they are in between X and Y axis, kita kena resolve mereka. Right? Kita kena resolve mereka. So I'm going to use this blue color. So if this is my F, I'm going to have Fx and also Fy. So I have another force along Y component. And then this is my W. Therefore, I'm going to have Wx and also Wy along my Y component. So now I have three forces along Y component. N, Fy and Wy. So saya akan ada N is along positive Y axis. So positive N campur dengan Fy ke bawah negative force along Y component campur dengan Wy pun ke bawah minus Wy is equals to 0. So basically your normal force here is going to equals to Fy plus with Wy. Saya bawa dua-dua ni ke kanan. Alright, negative become positive here. So we are going to find the normal force here. So what is my Fy is the force along Y component. Force along Y here. This is my force along Y component. So you can see here, you have F here. Kita ada theta 25 ada, theta 65 ada. Maksudnya you are given two angles here. I mean basically you identify lah dua-dua angle ni kita cari sendiri. So now, so tak kisahlah awak nak guna 65 atau you want to use 25. It's up to you. Since we are talking about the Y axis here, so cakap pasal Y axis, kita teruslah guna theta dekat sini. We're going to use 65, which means the theta here is touching Y axis. So I'm going to have use cos 65. So akan ada F cos 65. What is my F? 250. So masukkan nilai 250 dekat sini. 250 cos 65. And then campur dengan Wy. Wy pula, W is mass times W is mg. So kalau dia adalah Wy, what happen here is mg sin ataupun cos 65. So kita tengok balik theta mana kita nak guna. So you can see, you know the theta here is 25, sini pun kita tahu, tak ada masalah. So kita terus guna theta yang ini because we're talking about Wy and this theta is touching Wy. So kita ambil 25 terus cos 25 here. What is mg? M adalah mass, which is 20 gram here. So sorry, 20 kilogram. G is 9.81 cos 25. So tekan calculator. 250 cos 65 plus with 20 times 9.81 cos 25 here. So you get 283.47 Newton. So ini adalah nilai normal force kita. Alright, this is the normal force value. Okay, sebenarnya kita bukan nak cari kawan ni, betul tak? Apa yang kita nak adalah frictional force tadi. Okay, sorry, kita nak work done by the friction. Since you have managed to find your normal force, you're going to substitute this into here. Alright, kita nak substitute dia masuk ke dalam. So, work done by frictional force becomes mu ns cos theta. Mu dalam soalan given as 0.3. Normal force 283.47. S adalah 3.8. Cos is the angle between the frictional force and also displacement, which is 180. So 180 here. So you're going to press your calculator. 0.3 times 283.47 times 3.8. Alright, and then cos 180 is negative 1. So you'll end up with negative 323.16 joule. So this is the work done by the frictional force. Okay, disebabkan nilai frictional force is not given in the question. So kita tengok pada equation frictional force. How do you find frictional force adalah coefficient of the friction darab dengan normal force. So normal force is another value that we do not know in the question. So apa kita buat adalah kita berbalik ke chapter 4. We are going to solve the x-axis and also y-axis to find the normal force. Since normal is along y saja, so kita solve yang y-axis je lah. Summation Fy sama dengan kosong because the object is not moving along y-axis. Okay, dia tidak bergerak along y. So kamu pun masukkanlah semua forces yang you have along y, and then you find your normal here. Then you can substitute into this equation to get the work done by the frictional force. And then lastly, the last question here is to find the total work done. To find the total work done, apa kita akan buat lah? We are going to add all the work done by all the forces that acting on the object. Okay? Kita tengok balik soalan. Kita ada berapa banyak forces acting on the object. So basically what you have here is, you have normal force 1, external force 2, tak ada weight 3, and then you have friction 4. So you have 4 forces here, therefore you are going to sum all these 4 forces work done. So work done by the normal force, work done by the frictional force, work done by the weight, and also work done by the external force. So kita actually dah cari semua work done by external force dah ada, question A. Work done by the gravitational force dah ada, question B. Work done by the reaction force normal, question C. And then work done by the frictional force, question D. So you have actually find all the work done. So sekarang tinggal nak tambah sahaja. So work done by normal plus work done by gravity plus work done by external force plus work done by the frictional force. So normal 0. Gravity gives you tadi negative 315.09 plus weight. Frictional force pula, external force tadi adalah 860.99 plus weight by frictional adalah negative 323.16. Alright, then press your calculator. Negative 315.09 plus 864.99 plus 323.16. So you get your total work done here as 222.74 joule, and you get a positive